Hello everyone, my name is Guangbin Huang, and in this lecture tutorial, I will go through face recognition and teach you how to recognize faces by using artificial intelligence. Let me do a very brief introduction. I did my master in Queen Mary, University of London about computer vision, and now I'm doing machine learning in Deep Blue Tech based in Shanghai. I'm also one of the co-author of TensorRT Pro. So if you want to know more about TensorRT Pro, you can go to GitHub to check it. So on the right part, this is one of my selfie. Yeah. Without further ado, let's go straight to the point. Okay, let's talk about the overview of the face recognition, and we will go through all stuff like the following parts. So first, we will talk about the background of face recognition, then the history, and the third is about dataset. So which dataset we are going to use for face recognition, and the last but not least, we will talk about how to measure the performance of the algorithm of face recognition. Now I'm going to start with two very basic tasks in face recognition. The first one is face identification. So that means you need to identify a face. And the second is face verification. So you need to verify two faces. Okay, so let's look at these three pictures. So face identification means you need to identify. So the first one is Jackie Chan, and the second is Michael Jackson, and the third is Leonardo DiCaprio. So you need to identify their name. But in the task of face verification, it would be easier. So given two images, for example, they are Taylor Swift's. But now let's assume that we don't know these two pictures come from a same person, Taylor Swift. We just compare their similarity to conclude that whether these two pictures are the same person. So if they are the same person, so the system will return true, otherwise false. So for example, this girl, Elizabeth Olsen, is not the same person as the right one. Okay, it's also Taylor Swift. So here's a funny question. Why it's hard to recognize a face by a computer? So let's use this example. We have a Jackie Chan, a photo of Jackie Chan, and as a human being, we see this photo as a human because that's what we can see here. But as a computer, so what a computer can see is a tensor or a matrix with a lot of digits in its column and row. So if we still remember the simplest dataset in computer vision, which is MNIST. So this is 8. We have 8 digits here. So this 8 digit is made up by a lot of digits. That's equivalent to say we need to train our computer to recognize this matrix into a face. So that is not an easy job. Some people want to know whether we have other ways to recognize a person. Of course we do. So we have voice recognition, fingerprint, iris, heart rate sensors, but those ways have shortcomings. For example, if we only use fingerprint scanning, let's say we need to arrest a bad guy in train station. It's impossible for a policeman only use fingerprint because you need to touch the fingerprint scanning device. So it's not so quick, not so easy to do that. But if we can use facial recognition, we can use the cameras installed in the train station. We can catch a lot of images so that it would be easier for us to catch, to arrest the bad guy. Let me introduce two methods to get the data because we need to train the model. So we need to have a data set, or we take some methods to get the data. So the first method is get the data, get the photos online. We can use Python, Clara. And the second is we can use surveillance camera directly. We can get the image frame by frame. So these are the two main ways. Okay, let's do a very quick review, a recap. So the followings are the pros of face recognition. It's very easy to collect. There's no need to touch. Like it's different from like fingerprint scanning. We can also use multiplexes. That means we can catch images by using several cameras at the same time and analyze is there a person here and which person is this person. Okay, and last, it resembles human beings because as a human being we recognize a person most of the time we use our eyes. So we here as a computer we also spend more time on computer vision. What kind of application do we have for face recognition? Obviously, the first one is really easy to remind, is intelligent security surveillance system in railway or airport. The second is Face ID on your phone. Just like each time you swipe your iPhone, you need to put your iPhone in front of your face. So your iPhone will recognize who you are. If you are you can enter your iPhone. And door unlocking system, so it's similar as the Face ID. And some people might be worried about the privacy issue. We also have some application related to not so privacy sensitive. For example, we have smart checkout system. We also have some functionality to find similar products. So let me just introduce smart checkout system briefly. Just imagine you enter a restaurant and you pick up some dishes and you just like this image here, and you put them together on one dish, on one plate. And when you pass by the checkout system and you put your plate under the camera, and the camera will tell you, and the system will tell you how much you're gonna pay. So the system also use a similar algorithm as face recognition, because the system needs to recognize. So here we have a steak, we have some spaghetti, we have some broccoli. So we have three dishes. So how much are we gonna pay? As for the last one, so find similar products. If you often go to Amazon to buy something, you will find we can use a functionality to find some similar products, and then we compare the price and we choose the one with the lowest price. So we buy it. Okay, finally, let's talk about challenges. We already have sort of face recognition or face recognition alike algorithm, but we still have a lot of challenges we need to overcome. For example, if two persons or two staffs are twins, or some celebrities, they look alike, or we only have low resolution images of these persons, even for a human being, is very difficult for me to recognize, okay, are these two persons are the same person? And we also have some pose issues. So let's see here. So Bill Gates might be captured in different poses. So is it still going well when different poses happen? We also have age issue, because each person might might getting old. So is it still possible for us to recognize, okay, this young person, this young Bill Gates is the one older? Okay, the last part, let's do a summary. So in the previous slides, we've introduced two simple tasks. So particularly, the first one is face identification and face verification. And then we go on to face recognition and other biometrics, and we compare them, we compare the pros and cons, and we find that face recognition is very efficient. It might not be the perfect one, but it still be the most efficient. And then we talk about the approach to collect data. We have two approaches. Then we talk about applications, and finally we end up with challenges.